Welcome to the first and introductory lecture of Agentic AI series, in which our goal is to cover Agentic AI from zero to mastery. But before starting the introductory lecture of the Agentic AI series, I want to tell you what is not in the scope of our series. This is not your regular 9 rupee class. In this lecture series, we are going to cover Agentic AI from zero to mastery. It means that after this lecture series, you will be capable to create your own AI agents. Okay? So, firstly, we are going to discuss LLM versus AI agent. That is, what is the fundamental difference between LLM and AI agents? Yeah. So, let's read the definition firstly. LLMs, it is next token predictor, which is trained on massive amounts of data. LLMs are stateless. So, what is LLM? LLM simply just predicts the next token, right? And it is trained on massive amounts of data. And what do you mean by LLMs are stateless? We are going to find in our practical demo today itself. But firstly, let's discuss what is AI agent. An AI agent is an autonomous or semi-autonomous software system that is designed to achieve a specific goal. Agentic AI is stateful. So, what is agentic AI? So, agentic AI has a defined purpose to achieve a specific goals, and agentic AI is stateful. So now we are going to see the practical demonstration for what do you mean by stateless and stateful. So let's go to our VS Code. Okay. In the later part of the lecture series, we are going to cover how I have written the code, the process that I have followed to write the code. But for now, this is not the scope of this lecture, but this is surely the scope of this lecture series. So first, I'm going to run this our llm.py Python file. Okay. Python 3 llm py. By writing this statement on your terminal, you simply tell your VS Code that I want to run this Python file. Okay. So, firstly, let's discuss what is this Python file about. Okay. So, we have just defined our model, which is Llama 3.1, which has 8 billion parameter. And this Python file is going to ask us two user prompts, right? What do you mean by LLMs are stateless that we have discussed in the PPT just now? It means that LLM doesn't have context of its previous conversation, but AI agents do. What the LLMs that you use in the form of Chat GPT, Gemini, are not LLMs. They are AI agents. Let me show you the functioning of an LLM. Right. So this LLM is asking me a user prompt. So let us give them a user prompt. Right. So for example, let's write a sample prompt. My name is Aditya Kumar, and I love agentic AI. Tell me very briefly, Briefly, pardon my spelling so that I know the spelling of briefly is right. Tell me very briefly about agentic AI. Sorry for that slash. So now the call has been, now I have written the user prompt, and now the call has been hit to the API. Since we are using Olama here, which is a locally hosted LLM, it means that I have downloaded that LLM in my system. There is no API key here, but the LLM is running on the background, computing its calculation, or you can say computing its attention, and will give me a, what you can say, an output, right? It will take a time because my laptop doesn't have a dedicated GPU. It has an integrated GPU, also called as iGPU, but doesn't have a dedicated GPU, right? If you don't have dedicated GPU, there's slight problem, but without dedicated GPU also, you can pursue your AI, agentic AI. What you can say? You can pursue this agentic AI series, right? So let's read what is the output given by our Llama model. Nice to meet you, Aditya. So it has recognized that my name is Aditya, and it has given the, what you can say, some information about agentic AI. Let's read. Agentic AI refers to artificial intelligence that exhibits goal-directed behavior, very good, autonomy, very good, and decision-making capabilities similar to those of humans or animals. It is the type of AI that can perceive its environment, make decisions, and take actions to achieve specific goals, often in self-interested manner, right? So now I'm going to ask the LLM. that what is my name, what is my name, and what do I love. So if you do this experiment in your chat gpt, the chat gpt that you log in via web browser, or Gemini that you log in via web browser, not by coding IDE, right? Via web browser, it will return that. For example, if I have written the same prompt, the same series of prompt in web based chat GPT, so what do you expect that it should return? It should return, my name is Aditya Kumar and I love agentic AI. Yeah, very natural response. But let's see what has our model returned. I am happy to chat with you, but unfortunately, I don't know your name or any personal preference, right? So it doesn't know my name or personal preference. But if you do the same experiment with your web based chat GPT, it will give my name as Aditya Kumar and it will give agentic AI as my love. Yeah. I love agentic AI. So, we can say that LLMs are stateless and agentic AI is stateful. So this is the example of your basic LLM, right? So let's move to our PPT. And so now we are going to discuss, this is the last part of the lecture, model type on the basis of accessibility. Okay. Because why are we discussing the types of models? Because the brain of our agentic AI is LLM. Without LLM, we cannot build AI agents. Or we can build, but it is not as advanced as the agentic AI that we build via LLM. Because if we don't build our agentic AI via LLM, it will give a very deterministic response. Or you can say the responses are hard coded. But we don't want the responses to be hard coded. The responses should be according to the user prompt. So we can say the LLMs are the brain of our agentic AI systems. Okay. So we have to discuss the types of LLMs that we have to use in the future. So firstly, let's discuss closed state models. Can I make a pointer? Yeah. So closed state models. These are the types of models that I assume you have used generally, like ChatGPT, Gemini. Let's read the definition. Proprietary models hosted by a provider where the weight, source code, and training data are completely hidden, accessible only via an API interface. This thing you have to put a lot of focus on this 3 4 words. Accessible only via an API or interface. For example, OpenAI GPT, Anthropic, Claude models, and Google's Gemini models. So these types of models you cannot download on your system. You can only access this type of system via an API call. Let's discuss now open weight models. The model that I have used currently to demonstrate what is LLM in this lecture is an open weight model offered by Facebook called as Llama 3.1. Let's read the definition. Models where the final trained parameter weights are publicly released for you to download and run locally. This thing I have demonstrated you today, but the exact training data set and code remain private. Why do you think that the data set remains private? Because they do not want to show you in which data set they have trained, because it might be possible that they have trained on not publicly available data set which is wrong, which is actionable in the code. So to hide that or to not disclose that, they hide the training data set and the code remains private. For example, Meta Llama 3.1 that we have used just now, Mistral 7 billion parameter model, I think so, it means this, and Google Gemma 2 model. Now let's discuss open source models. Fully transparent. What do you mean by fully transparent? Fully transparent models that publicly release everything. You know everything about the model, open source model, including model weights, complete training code, architecture design, and underlying dataset under open licenses. Sorry for that. This is the main difference between open source and open weight models. In the open weight models, you know the weights of the models, but in open source model, you also know the underlying data set, architecture, architectural design, complete training code. So yeah, this marks the end of this lecture. I hope to see you in the next lecture series of the Agentic AI soon.